2. Hey everyone, and welcome back to the channel. Today, we're diving deep into a classic yet crucial topic in restorative dentistry, amalgam preparations. If you've ever wondered how to get those perfect, long-lasting silver fillings, you're in the right place. We're going to break down everything from basic principles to specific techniques for different cavity classes. By the end of this video, you'll have a solid understanding of how to achieve strength, seal, and retention for your amalgam restorations. Let's get started. First things first, let's talk about the big three requirements for any successful amalgam prep: resistance, retention, and marginal integrity. Resistance form is all about making sure the filling and the tooth can withstand chewing forces without fracturing. Retention form is what locks the filling in place, preventing it from getting dislodged. And finally, marginal integrity ensures a tight seal between the filling and the tooth, which is key to preventing secondary decay. Mastering these three concepts is the foundation for everything else we'll discuss. So let's start with resistance. Amalgam is strong under compression, but it's quite brittle, meaning it can easily fracture if it's too thin or not properly supported by tooth structure. This is a critical point to remember. To prevent this, we need to ensure our amalgam has enough bulk. The magic number for occlusal thickness is generally 1.5 to 2.0 millimeters. Any less than that, and you're running a high risk of the amalgam cracking under occlusal load. Another key aspect of resistance form is the cavosurface margin, that S, the angle where the prepared cavity wall meets the external surface of the tooth. For amalgam, you want to create a 90-degree butt joint margin. Think of it like a sharp, clean corner. This 90-degree angle provides the best support for the amalgam, preventing the edges from chipping or breaking away over time. If the angle is too sharp or obtuse, the amalgam margin will be thin and weak, making it prone to fracture. So, always aim for that strong, 90-degree box-like design. It's fundamental for longevity. Now, let's move on to retention. Unlike composite resins that chemically bond to the tooth, amalgam relies entirely on mechanical retention. It's like a puzzle piece that gets locked into place. The primary way we achieve this is by creating what's called occlusal convergence. This means the walls of the preparation are designed to be slightly wider at the floor of the cavity than they are at the occlusal opening. Imagine a slight undercut. This dovetail shape physically locks the amalgam in place once it has set, preventing it from being pulled out. But what if the tooth has lost a lot of structure and primary retention isn't enough? That's where secondary retention features come into play. We can add things like grooves, slots, or even pins to provide extra grip. Grooves are small channels cut into the dentin, usually at the line angles of the prep, that give the amalgam extra surface area to lock into. Pins are tiny threaded posts that are drilled into the dentin, with the head of the pin extending into the space that will be filled with amalgam. These are more for very large restorations, where a significant amount of tooth structure is missing. The key takeaway is that you must create mechanical features to hold that amalgam in. Let's touch on a few general principles. One of the unique and fascinating properties of amalgam is its ability to self-seal. Over time, the margins of an amalgam filling undergo a process of corrosion. While corrosion sounds bad, in this context, the corrosion products actually fill the microscopic gap between the filling and the tooth. This process, known as percolation, helps to reduce micro-leakage over the long term, which is a major advantage. However, right after placement, there is a gap. To protect the pulp from sensitivity and initial leakage, we often use a cavity varnish or liner. Varnish acts like a sealant, plugging the dentinal tubules and minimizing that initial post-op sensitivity. It's a simple step that can make a big difference in patient comfort. And a final tip: don't rush to polish. Amalgam needs time to fully set and gain its maximum strength. Polishing too early can damage the margins and weaken the restoration. It's best to wait at least 24 hours before you bring out the polishing burr. Delayed polishing allows the material to mature and results in a smoother, more durable final surface. Okay, let's apply these principles to specific situations, starting with a Class 1 restoration. These are the most straightforward preps, typically involving the occlusal pits and fissures of posterior teeth. The goal is to be conservative, only removing the carious tooth structure. Your outline form should follow the main grooves, creating a smooth, flowing shape. As we discussed, depth is critical. You need to ensure you reach that 1.5 to 2.0 millimeter depth to give the amalgam enough bulk for strength. A common mistake is making the prep too shallow. Use your burr depth as a guide. When preparing, it's also vital to preserve the marginal ridges, the raised enamel borders on the mesial and distal sides of the tooth. These ridges are crucial for tooth strength, so your preparation should stop short of them unless they are undermined by decay. Now, let's level up to Class 2 restorations, V. This is where things get more complex because we're now dealing with the proximal surfaces, the surfaces between teeth. A Class 2 prep has two main parts, the occlusal portion, which is similar to a Class 1, and the proximal box, which extends down the side of the tooth. The primary objective of the proximal box is to remove the proximal decay and create clearance with the adjacent tooth. You need to break contact facially, lingually, and gingivally. This clearance is essential for placing a matrix band and for allowing the patient to clean the area. The walls of the box should be convergent towards the occlusal to help retain the amalgam, and the gingival floor should be flat. A key feature you'll often see in a classic Class 2 amalgam prep is the reverse curve, sometimes called an S-curve. This curve is on the facial wall of the proximal box as it blends into the occlusal outline. What's its purpose? It allows you to create that 90-degree exit angle at the proximal margin while conserving the facial cusp triangular ridge. Without it, you'd either have to cut away more tooth structure or end up with a weak, unsupported enamel margin. 3. Tension. In a Class 2, we rely heavily on the occlusal portion. This is where the dovetail feature becomes incredibly important. The dovetail is a fan-shaped extension of the occlusal prep into a groove that is indirectly connected to the proximal box. This acts as a lock, preventing the entire restoration from being displaced sideways or proximally. It's the primary anchor for the whole filling. When you're packing amalgam into a Class 2 prep, you can't just freehand it. You need to recreate the missing wall. This is where the matrix band and wedge come in. The matrix band is a thin strip of metal that wraps around the tooth to form the temporary wall of the proximal box. The wedge is a small, triangular piece of wood or plastic that's inserted at the gingival margin. The wedge has two jobs. It seals the gingival margin of the box to prevent amalgam from squeezing out, and it slightly separates the teeth, ensuring a tight contact point once the band is removed. Proper placement is absolutely critical for achieving the correct contour and a good proximal contact. Finally, let's briefly look at Class 5 restorations, Ds. These occur on the cervical third of the facial or lingual surfaces, often near the gum line. They're typically caused by abrasion, erosion, or decay. Because these are smooth surface cavities, they don't have natural retention from pits and fissures. Therefore, we must create it. The prep shape is often kidney bean or crescent shaped. For retention in a Class V, we rely on grooves. After preparing the axial wall to a uniform depth, you'll cut small retention grooves along the incisoocclusal and gingival walls using a small round burr. These grooves physically lock the amalgam into the preparation and prevent it from popping out, which is a common failure mode for these restorations. The external walls should diverge slightly to provide strong enamel margins. So, let's quickly recap the high-yield takeaways for rock-solid amalgam restorations. 1. Always ensure 1.5 to 2.0 millimeters of depth for occlusal strength. 2. Create 90-degree cavosurface margins to prevent fracture. 3. Use occlusal convergence and features like dovetails for mechanical retention. 4. For Class 2 preps, use a reverse curve to conserve tooth structure and get a strong margin. 5. Always use a properly placed matrix band and wedge to create a good contour and tight contact. And 6. For smooth surface preps, like a Class V, add retention grooves. By consistently applying these principles, you can create amalgam restorations that are not only functional, but also incredibly durable. Serving your patients well for many years. It's a material that has stood the test of time for a reason, and mastering these techniques is a valuable skill for any dentist. Thank you so much for watching. I hope this detailed breakdown was helpful. If you have any questions, drop them in the comments below. Don't forget to like this video if you learned something new, and subscribe for more dental content. See you in the next one.